Okay, today we're going to talk about interactions here, and we're doing Coulomb's law. So fun. So, what is Coulomb's law? So, there's three parts to Coulomb's law. Part number one is that there are two types of charge. Two types of charge. Right? Do you know what they're called? They're called positive and negative. Oh, how's that? I'll put a minus sign to be consistent. Anyways, so one thing to keep track of in your mind is that positive and negative are just names for the type of charge. There's nothing negative about an electron. It's just a particle with a particular type of charge that we call negative. It just has the opposite charge of a proton, and a proton is a positively charged thing. There's nothing positive about it. It just has a charge that we've called positive. Alright, just like magnets go to north and south. The only reason why they're called that is because of which way the compass points. Alright? So the part of a magnet that's north points towards the north. There's nothing related to north about it except that. Alright? So that's the first part of Coulomb's law. Anyways, the second part is that charge cannot be created, only separated. Okay, so what do they mean by this? What they mean by this is that you can't just generate any charge by itself, okay? So let's pretend you had a jar of atoms and you wanted to make it positively charged. You couldn't just take away their electrons randomly, okay? I mean you could, but what you're going to do is you're going to generate an area of negative charge and an area of positively charged. You can't do one without doing the other. They will always be lined up, so there's always going to be that opposite charge that's generated. If you drag your feet on the floor because, you know, that's what kids do, to get that static charge on your body, you are also generating the opposite charge on the ground itself, okay? So you can't generate one charge without generating the opposite charge somewhere else. That's what they're saying. Number three is something you've heard before, so opposite charges attract. And like charges repel. Right? Now remember, there's nothing special about two negative charges except they just happen to have the same type of charge and they don't like each other. That's it. There's nothing negative about it. It's just they have a matching charge. They could have called them male charges and female charges, you know, and it'd function exactly the same way. Alright? So there. Now we're going to be talking about the third chunk of this here for the attract and repel a lot today. That's the main one here. So the first thing we're going to do is we're going to talk about how charge affects this. Okay? So let's pretend we have a positive charge right there and we have a negative charge right there. And I am going to nail this one to the board or screen, whatever. So the negative one's not going anywhere. Okay? Now, what's going to happen to this positive charge? Is it going to go to the left, or to the right, or to the up and to the down? Which way is it going to go? Hopefully you said it. It's going to go to the right. It's going to want to go this way. Very good. Now I've got situation number two. I've got an equal positive charge here. And I've got a bigger negative charge. This is a doubly negative charge. Okay? And I'm going to nail it to the wall here. So what's going to happen to this positive charge? Is it going to go to the right, to the left, to the up, to the down? It's going to also go to the right. But what's going to be different? it's going to want to go to the right more than the top one, okay? And that's what matters here. So the charge, it's proportional to the force. Can I say force? I'm going to say force anyways. No one disagreed with me here in this room. So what this means is the more charge you have equals the stronger pull. Alright, so they're proportional. Does that make sense? Oh, I forgot the N. Overrated letter anyways. So, cool. So that's how the charge interacts within Coulomb's law. Now there's one more thing we have to take into account, and that is distance. So fun. So let's say we've got that positive charge again, and we've got a negative charge right there. This one is going to be plastered to the wall. This one is going to get pulled to the right. I'm sure you've figured that out by now. Alright, so I've got the positive charge here, and I'm putting the negative charge over here now. So I'm going to stick this one in. Alright, so what's going to happen now? Is it going to get pulled to the right? I agree with you. Is it going to be pulled more or less? It's going to be pulled less. The force is not going to be as strong. So what we know then is that distance, right? I'm going to say the reciprocal of distance is proportional to force. Okay, so what this means is the less distance is equal to the more pull or push. You know, it doesn't matter which one. Okay, now that's technically a lie. In reality, this is a square because of the inverse square law, but we're not going to worry too much about that. What you need to be aware of is that the closer they are, the stronger the pull or push is going to be. Alright? And that's what matters. Alright?